so what we have is particle is projected down an inclined plane with initial speed u. The plane is inclined at 30 degrees to the horizontal. The line of projection makes an angle of 60 degrees with the vertical line with the inclined plane. The plane projection is vertical, contains the line of greatest slope. The coefficient of restitution between the ball and the inclined plane is e. Find the range of the first hop in terms of u and e. Now, it's the first hop, okay, not the first throw. So what happens was what happens is there's a throw, okay, and in this throw, I think I need a new diagram here. Okay, so you're going to throw it first, and then after you throw it, there's going to be 2 bounces. Okay, there's going to be more than 2 bounces, but for the time being, I'm just going to assume it's 2. And so your initial throw is thrown at 60 degrees to the horizontal. It comes up, then comes back down again. Bounces here, okay? So our job is to find out the phi x and phi y just before impact, okay? Then once that happens, it's going to rebound back up again, and that's going to go down again. And then after that bounce has occurred, as it turns out, I'm going to need a longer line. And after that bounce occurs, there's another bounce, which I'll put in red here. And what we're going to say is that the red bounce is twice as long along the x-axis, okay? So the red bounce is going to have this red line here, which is the range of the x bounce, is twice as long as the blue bounce, okay? The first one isn't a bounce because you threw it, okay? So it doesn't count, right? You break up your velocity. It's 60 degrees, right? And that's u. So what's u sine 60? Anybody? Sine 60 is root 3 over 2 u. And cos 60 is u over 2. You then got to do your gravity triangle down here. Using something else other than that. Gravity triangle going straight down to left and back down again. So that is going to be angle of is it 30 degrees? The plane 30 degrees makes that 30 degrees. This makes that g cos 30. And what's g cos 30? Anybody? What'd you say? Root 3 over 2 g. And g cos 30, or so g sine 30 is g over 2. You then go and make your 4 equations. U plus at, so u over 2 plus a half gt. Your sy, the u along sy being 3 over 2u, which is the 3 over 2u here. And then your acceleration of against that is the root 3 over 2g working against it. There's your root 2 over 3g working against it. And then you modify that to make the sx and sy by adding in t, half in the second, the acceleration, and adding on another t. So, long story short, we have these 4 equations to work with. Okay, so I'll just bring them down there, and I'll start working with them now. So, step 1, find time of flight. Find time of flight. Okay. Now phi x and phi y. So we're going to say sy equals 0. When sy equals 0, this one here equals 0. Then what we're going to get is root 3 over 2 equals ut equals root 3 over 2 gt squared. And then the t's will cancel. The root 3's will cancel. Huh? It is root 3 over 4, you're right. I was looking at the I think I was looking at this one here by mistake. So root 3 over 4 is correct. So then we bring that up, and it's going to be 4u over 2g, which is going to be 2u over g. The time of flight is 2u over g. Okay. Now that we have that, we have to find our phi x and phi y. Phi x is going to be u over 2 plus a half gt, which is going to be half g into 2u over g. The g's will cancel, and what we're going to be left with is u over 2. A half 2u is u, which gives me 3u over 2. Phi y is going to be root 3 over 2. We're expecting phi y to be negative, right? Because it's on its, we're here, and we're looking for phi x and phi y. And we know that it's phi y is the this component here, and phi x is this component here, and the actual velocity is coming down to hit it. So, going to do here is phi y equals root 3 over 2u minus root 3 over 2u by 2u over g. It's going to be root 3 over 2. There's a g in there somewhere I'm looking for. Instead of u. Thank you. The g cancels, and it's going to be minus root 2u, u, root 3u. So I'm going for minus root 3 over 2 u for phi y. Now, what's happening now is we're just at the stage of the second bounce. We're coming in and we're going back out. So we'll just take a little zoomed in look. You're going in and you're coming back out. Now there's two components. Your component is you're going down at root 3 minus root 3 over 2u, and you're going to the right at 3u over 2. Now on the way out, which is in green, what are we looking at now? Which part is affected by the collision? The y value is affected by the collision, which means reverse the sign and multiply by the coefficient of restitution, which is going to be root 3 ue all over 2, and the other component remains unchanged. Now we have the job of rebuilding all four equations to find the range. Okay, so we're just going to move down our previous work, which is here. Okay, and you're just going to modify this to suit your new new system. Okay, let's start off with phi x. Phi x is only being, it was u over 2, now it's 3u over 2. So we're just going to change that to a 3, and we're going to change that to a 3. That's a real time saver right there. Okay. Next thing we're going to change is root 3 ue. Okay, so there should be a, yes, what?
It will not be 3 over 4.
For which one?
For the x and sx.
One sec.
Since u changes to 3 over 2.
So it's a quick question about the u over 2 from the last part. The u over 2 and root 3 over 2u, where the angle was already used to break it into its components, u over 2 and root 3 over 2u. However, in this part of the question, you can see that's already broken up into its components. So this is a ux and uy, and the formula is u plus at. So phi x will be ux plus at. So it's already broken up into its components, which makes that 3u over 2. And in the case of this one, there's just going to be an e put in at the end. So ute and ute. Okay? Because it's the difference between the this is now the uy, the velocity, the initial velocity for the y direction, which will be present. Oh, I see what I did there. Excuse me. That's not the one. It's meant to be here. Is that what you're about to say? Okay. So you can see that it's there and there. The e is present. Okay. Now, once again, we're going to have to go through the exact same procedure. We're going to be just have re-look at your diagram. We're going to find out what the blue distance is. It's the range, and after we find the range, because the range is where the marks are going, we're then going to find phi x and phi y at the point after the first hop. The reason being is we need to find that the range is the answer to the first question. The answer to the second question is what value is the second hop. Yes.
I did this out last night, sir, and they said that there's only
Now, What we have here, guys, is this here. So we're going to do phi x and phi y and sx and sy. So sy equals 0 and sy equals 0 is put that equal to 0. So we're going to get root 3 over 4 gt squared ends up to be root 3 over 2 ute. The t cancels with that t, and the root 3 cancels with root 3. It's basically the same as last time, except there's an e involved, isn't there? So it's going to be 2u e over g. Then we're going to find our sx, which is our range. Okay, so sx is a range. It's going to be 3u over 2 times t, which is 2u e over g, plus a quarter g. Now we're going to square this, and we're going to get a 4u squared e squared all over g squared, and then sx is going to be 6u e all over 2g e squared. There's an e there, wasn't there? Oh, u squared. Oh, sorry. U squared, right? Plus a quarter. The 4's cancel, don't they? So it's going to be u squared e squared all over g. Now, I'm just after seeing a pattern here, okay, this is regards to wording of the question. I think we're going to have to follow through with what Tom said. Now, just let me explain why. See the way this one has an e squared? What do you think the next one's going to have? E to the power 4 or something like that. So it's going to be absolutely ridiculous. Okay, so just for the sake of this, okay, we're just going to accept that the question was badly worded, and it's that the first hop here. This isn't going to be drawn to scale now. It's that the green distance, the blue distance is twice the green distance. Is that right? Because that's the only way we're going to get it done. Because if we go through another set, we're going to have so many e squares. It's not going to be worth doing. It's going to be e to the power 3 or e to the power 4, which you're never going to be asked a question like that. So it's pointless to do it. So what we want to say is that this sx here is twice the other range. And what was the other range we got that time? Probably rubbed it out, did I? I didn't have to get it, did I? Now? Okay, so brilliant. Okay, so what we're gonna do is we know from the first part t was 2u over g. Was that right? Yeah. Sx is the modified version of that, so it's just ut over 2 plus a quarter gt squared. Tom, you just keep it in mind. This is make sure it works out here. And then it's going to be u times over 2 times 2u over g. This is going to be u over g. Then it's going to be a quarter g times 4u squared over g. It's going to be u squared over g, yeah?
G squared.
This one? Oh, yes. G squared, thank you. And then the 4 will cancel with that 4 there. The g cancels with that one there. Is that another u squared over g then? And then the range of the first bounce / throw is 2u squared over g. Good with that. Now, what it's saying is that the second hop is twice that. So the second hop should be equal to 4u squared over g. So this second hop is 4u squared all over g. You have an equation. Now this one here, they don't all have the same denominator. Let's turn that into an 8, that into a 2, that into a 2, that into a 2. Cancel all of them. The u squareds can disappear as well. And we're going to be left with 6e plus 2e squared equals 8. Hoping this works. divide by 2, bring the 8 over the other side. We're going to get e squared plus 3e minus 4 equals 0. What do we know about e? Has to be, huh? 0 and 1. Is that going to happen?
Yeah.
E squared, e plus 4, yeah? E minus 1 equals 0. E has to be equal to 1. You don't even have to work out the other ones. Minus 4 can't happen. So the answer was E equals 1. So what they should have said was, if you really want to modify this question, they should say a particle projected down. So they'd have to change that to a particle bounces off an inclined plane. So, or hops off an inclined plane, and then that's the modification of the question to fit that answer. Okay.